Welcome back everybody to another free installment of our Scantime tutorials. Today we're going to be having a look at Siemens STEP7 professional counters and why we don't really use them inside of our programs. Now before we get started with that, what I'd like you to do is leave a like on the video, leave a comment, and if you're watching us on YouTube, hit the subscribe button. It helps us out a lot. Now before we can look at the problems with Step 7 counters, what we need to do is we need to actually see how a counter inside of a PLC should work. So what we're going to do is we're going to use Siemens TIA portal and we're going to create a counter inside of that project and see how that counter works inside of the project. Then we're going to show you the problems with it inside a Step 7 professional. Let's get started. So on my screen at the moment I have Siemens TIA portal open, and what we're going to do is we're going to create a basic program to operate a counter, and we're going to see how a counter works. Now the main specific thing about a counter inside of all PLCs is that a counter counts events, and when it hits a certain number of events, what it then does is then turns on a signal which we can then use in our program to do whatever else. So let's see how a counter works. On the right hand side inside of our basic instructions window we have a folder called counter operations. If I open that up we're left with 3 counters. Now I'm just going to focus on the one counter today, and that there is the CTU. Let's drag and drop that into network 1, and the first thing it's going to ask me for is a data block. This is an instance data block which goes alongside the actual counter inside of TIA portal. Inside of Step 7 we don't have to do this, so this is unique to TIA portal. I'm just going to leave it as default and just say OK to that. And a counter is now inserted into our program. Now what we're going to do is we're going to add in a normally open contact, and I'm going to tie this to M0.0, and that there is going to our counter up signal. And what this is going to do is it's going to look at the 0 to 1 transition, the rising edge signal on our M0.0, and when it sees that rising edge signal the counter is going to count 1. Doesn't matter how long the signal is on for, it could be on for 1 second, it could be on for 1 day, it's only going to count 1. When the signal turns off and then turns back on again, it'll count 2, 3, 4, 5. And what we want to do is we want to count up to, let's say, 6. So to do that, inside of the PV, I'm going to change the PV to 6. This is what value we are counting to. And what I want to do is I want to turn on an output coil. We'll just say Q0.0 when the counter has finished counting to 6. And unlike a timer, when a timer loses its enable signal, the timer resets, a counter doesn't. With a counter, you need to manually reset that counter using its R signal. That R signal there is the reset, and all we'll do is we'll tie this to M0.1. Let's save our project, and then let's download this to our Siemens S7 1200 PLC. Stop the PLC, load that to the PLC itself, and start it all up again. Okay, let's minimize that. Let's click the glasses and go online. And let's minimize this window. Okay, so what a counter should do in a PLC, and what it really does in all PLCs apart from Step 7, is when an input signal turns on, it counts that signal, it counts a specific number of signals, and when it hits that amount, it then turns on the output condition to say it's completed counting. So let's just see how this works. I'm just going to right click M0.0, modify it to 1. The signal then turns on and my counter counts to 1. If I reset that signal back to 0, it's still at 1, it doesn't lose its count value. I'll then trigger it again. It counts to 2. Reset that. Trigger it again. It counts to 3. Reset that signal. 4. 5. And then finally, when it hits the value 6, that's when the output coil turns on. And then that tells us that we've completed our count, and then it can proceed to do whatever it needs to do next. When the input signal turns off, we then may want to reset the counter, and all I'll do here is I'll trigger the reset, and what that does is it resets my counter back to 0, ready to start counting to 6 again. So that's how it works inside a TIA portal. And as I mentioned, inside a Siemens TIA portal, counters work fine. We've got no problems, no issues there. the problems occur inside a Step 7 Professional. So let's take this counter design and let's design that inside a Step 7. So here I've got Step 7 open with us, and what I want to do is I want to open up OB1. It's going to ask me to create the block. I'll create it in ladder and I'll just say OK to that. So inside of network 1, what we're going to do is we're going to add in our normally open contact, and we're going to tie that to M0.0. And on our left hand side, here's our counter folder, and you can see there we've got 6 counter instructions. We've got the S_CU, we've got the S_CD, and we've also got the S_CUD, and then we have the SC, CU, and CD. These top 3 counters, these are S5 counters, and these bottom 3 counters, these are the new S7 style, which is more of an inline instruction. Now, if we don't use S5 counters inside of our PLC programs, we definitely do not use S7 counters. And again, I'm going to show you why later on. So let's add in our S_CU, which is our count up counter. And there it is there. You'll notice a few extra input and output parameters, but the first thing that we need to do is give this counter a name, and that counter is going to be C0. That's going to be my first counter. The M0 is connected to our CU, just like it is inside of TIA Portal. And what I want to do is I want to have this counter count to 6. So to set a count value inside of Siemens counters, you would set this to C#6. Enter that. There's our reset, just like we've seen before. M0.1, we'll set that to. And we'll set our output coil to Q4.0 for this S7300 PLC. We'll leave the CV and the CV-BCD blank. We don't have to have this for our counter to work. And you'll notice here some red question marks on the S parameter. What's this S parameter all about? Well, what we'll do is we'll assign it to an M bit anyways, and we'll have a look at what this does later on in the program. But there is our counter designed, ready to go. So we got our M0 going to our CU, just like our TIA Portal program. We've got our M0 going to our R, just like our TIA Portal program. We've got our PV set to 6, and we've got our output coil going to the Q on our counter. So what we're going to do now is we're going to save this, and we're going to download this to the PLC. Say yes to that, and then hit the goggles and let's go live. Okay, so there's our counter ready to go. So what I'm going to do is, just like I did in TIA Portal, I'm going to turn on the M0.0 just by toggling it inside of the program. And what we should see is the counter count 1 and nothing else. If I modify M0.0 now, as soon as I modify M0.0, the counter counts 1, but the output already turns on. You can see there inside of my program, Q4.0 is on. Well, we're nowhere near the preset value. We're nowhere near this 6. Right, well, what happens when we get to 6 then? So let's modify that to 0. Let's turn it on again. There, it counts 2. The output's still on for whatever reason. Turn that off. Turn it back on. It counts to 3. Turn it off. Turn it back on. 4. 5. And what happens when it gets to 6? Absolutely nothing. Nothing happens when we get to 6. So what does the PV do? Well, let's reset my counter first. So if I right click M0.1 and trigger that to 1, that actually resets the counter, so that at least works. Knock this back down to 0. Turn off my input. And let's trigger M0.2. Watch what happens to my counter value when I trigger M0.2. 3, 2, 1. Whack. It goes straight to 6. This set input and this PV input are used in the count down counter. And what that does is when the set turns on, it loads the preset value, which in this case is 6, and it loads it into our counter. If I 0 M0.2 and turn that off and then trigger M0.0, it just keeps on counting from 6. So there we go. We're now at 7. We're now at 8. And really, counters by themselves do absolutely nothing. All they do is effectively count, but they don't do anything when they've reached the set value that you wanted to count to. So how do counters work inside of Siemens STEP7? Well, you need other instructions to let them work. So what we'll do here is we'll just reset this back to 0 and turn our reset back off. And what we're going to do is we're just going to come offline. To have our counter work when it reaches the value 6, what we need to use is a comparator. Now what I'm going to do here is I'm going to delete my set bit and I'm going to delete my PV. And this here will show you that we don't need those instructions for this counter to actually do anything. So what I'm going to do is I'm going to create a new network inside of Step 7 and I'm going to add in my equals to comparator. And you'll see here that it's asking us for 2 values, input 1 and input 2. Now this input 1 is looking for the counter value itself. So we're going to compare the counter value with the value 6, and when it is equals to 6 it then turns on an output. So to do this, if I type in say 0, the counter itself, it doesn't allow it. Now for this to work, what we need to do is we actually need to assign this count value to a memory word. And what this will do is every time the counter counts 1, 2, 3, 4, it'll store that value inside of the memory word, and then we can use that memory word inside of our comparator. And then the comparator can compare the memory word to the set value that we want to reach, and then turn on an output when it reaches that condition. So for our CV, what I'm going to do is I'm just going to tie this to memory word 100, just a random MW. And inside of my comparator, I'm going to set this to MW100, and I'm going to set my comparator to 6. And there we go. When it reaches 6, what I want to do is I then want to turn on my output Q4.0, which means I can get rid of this Q here. All that Q did was just tell us that we're counting. It turned on as soon as our counter hit 1. Pretty pointless. Alright, all it did, like I say, is turned on to tell us that we're counting. So what I wanted to do is I want to turn on when our counter reaches 6. So here we've got our counter, and then we have our comparator underneath it. So let's save our work, let's download that new revision to the PLC, and now let's go to goggles. Okay, we can see here that MW100 is set to 0. And it's not currently equals to 6, so my Q4.0 isn't on. You can see here we don't have a set, we don't have our preset value, and we don't have a Q registered to this counter. All we really have registered to this counter is our count up signal, our reset signal, and our count value signal. So what I'm going to do here is I'm going to modify our count up signal to 1, turn that off, and you'll see our MW100 hit 1, and inside of our comparator, MW100 is currently 1, which currently isn't equals to 6. So if I now modify my M0.0 to 1 again, reset it, modify it back to 1, reset it, you will see my MW100 in network 2 counting. We're currently at 5, and now when I trigger this M0.0 once again, it'll hit 6, it'll then be equals to the input 2 on my comparator, turning on Q4.0, allowing our counter to work just like a counter should. Reset M0.0, and there we go. Q4.0 is now on when our counter hits 6. For this counter to actually work like a counter does inside a Siemens TIA portal, like a counter does inside a Mitsubishi or inside of Omron or inside of Allen Bradley, we need to have the counter and a comparator assigned with it. For me to reset this back to 0, hit the reset, and there we go. 0 is then moved into my memory word and into the counter. My memory word is now equals to 0, and the comparator is no longer true. Right, so that there is Siemens S5 counters. And like I say, you don't have to have this S, you don't have to have this PV, you don't have to have the Q. All you need is the count up, the reset, and the CV value, and then a comparator. So already you can start to see the downside of using counters inside of Step 7 as opposed to using them inside of TIA Portal. Inside of TIA Portal I have one network. All it does is it monitors M0.0. When it hits 6 it turns on my output. But inside of Step 7 I need two networks to do this. I need a counter and a comparator. Now I mentioned before that if we don't use these S5 counters inside of Step 7, then we definitely don't use the S7 counters. Let's have a look at how an S7 counter works. So what I'm going to do is just come offline and I'm going to create a new network below this, and what I'm going to do is I'm going to create this counter that we see here, and we're going to create the same version using the S7. Now you'll notice here the first thing inside of our S7 counter instructions is SC. That there is our set count instruction. If you remember the S and the PV inside of this S5 counter, that is effectively what that is. If we move that into our network and assign a contact to that, when this contact turns on, it's going to move whatever value is in here, let's just say 6 like it was before, into our counter. Now, because we already said we don't need this, what we're going to do is we're going to delete that network from the program. We only need that if we're going to use the countdown counters, which we're not. Create a new network, and what we want to do is we want to first of all create this part here, the M0.0 to the CU. So to do this, normally open contact, M0.0, and what we're going to do is tie it to our CU coil. And you'll notice here, it looks very similar to the S7 timers from our previous video. If you haven't checked that out, go to our YouTube channel or on our Facebook page. You'll see our video on an in-depth look to Siemens timers. So here we got like an inline instruction here, and it's asking you for the counter number. So here we give ours C0. We can't use C0 again, so we'll use C1. And there we go. Right. So all this does is when M0.0 turns on, it counts up the value inside of C1. Right, okay. So next what we want to do is we want to create a new network, and we need to create the reset portion of this counter, because again, this counter needs a reset just like every other counter. So again, I'm going to add a normally open contact. I'm then going to tie this to M0.1, and inside of this counter folder, you'll notice there's no reset instruction. That's because it's inside of another folder called BitLogic. Inside of our BitLogic folder, you'll see here is our reset instruction. If I drag and drop it into place, it then allows us to reset our counter C1. There we go. Okay, so already our counter is at two networks, and all we've done is we've created the count up signal and we've created the reset signal. That's it. We still have to have our comparator monitoring the actual value inside of our counter, and then turn on our output when we reach the count value, and we're already at two networks. Right, so create another network. And now what we want to do is go back to our comparator function, grab our EQ instruction, and what we want to do is we want to compare the value that's inside of our counter 1 signal with 6. So I'll type in input 2, 6, and for input 1, you'll notice, well, hang on, there's no memory word. There's nowhere we can assign a memory word to this C1. In this counter, at least we could assign this memory word to the current count value, but in this counter, there's nowhere we can actually assign a memory word. So, okay, let's try and type in C1, see if that works. And no, it's not accepted. You can't write in C1 to our comparator just like we couldn't before. So what do we do? Well, guys, we have to use another instruction. Right, so close down your comparator folder, open up your move instruction folder, and then drag and drop your move instruction into network 5. What we're going to do here is we're going to move the value that's currently in C1 into a memory word, and we'll just use the next one available, MW102, like so. Now inside of our comparator, we can write in MW102, compare that with 6, and then when it is equals to 6, turn on our output coil, and we'll use the next one, Q4.1. And there we go, guys. That's your S7 counter. 3 networks and 4 instructions just to create what we have inside of TIA Portal is just 1 network and 1 instruction, or at least what we have inside of Step 7 is just 2 networks and 2 instructions. Not much logic in that. Save our work, download this to the PLC, and let's see this in action. Alright, so you can already see our program. We just have 2 counters inside of our program, and we've got 5 networks. Right, so let's go online here. There we go. And what we want to do is modify M0.0 to 1. And you'll see here, C1 has the value 1. Our C0 has the value 1 inside of it as well as our MW100 and our MW102. Remember, in this network, we are moving the value from C1 into memory word 102. So now our comparators are both equals to 1. Right, let's modify this back to 0. Let's modify it back to 1. And now our counter is at 2. And now both comparators are at 2 as well. If we modify this back to 0, modify it back to 1, we're now with 3. Modify it back to 0, modify it back to 1, back to 4, 5, and then finally, when I trigger this again, now we're at 6. C1 is being moved into memory word 102. Our memory word 102 is now 6, which is equals to our input 2, which is now turned on Q4.1. And inside of our S5 counter, it's done exactly the same there as well. If I trigger M0.1, that there will reset our counters back to 0. Here we can see that this output here is off, and this output here is off as well. And that there is Siemens Step 7 counters in a nutshell. As you can already see, the sort of complexity that these counters need to actually just work like a normal counter is quite ridiculous. And this is just one of the reasons why we don't use counters inside a Step 7 Professional. Which is a bit of a shame, because Step 7 Professional is a great programming package. It's one of our favourites alongside TIA Portal. It's just the counters really let it down, especially when you're so used to using the counters in other PLCs. Anyways, that there is Siemens counters inside a Step 7 Professional, and a little bit about Siemens counters inside a TIA Portal. I hope you've enjoyed this tutorial. As I mentioned before, please give the video a like if you haven't already done so, leave a comment, and if you're on our YouTube channel and you're watching through there, hit the subscribe button to stay up to date with more free Scantime tutorials. I look forward to seeing you again. See you next week.